So these are your perfect squares. You need to know perfect squares for these. So your perfect squares. So the smallest perfect square is 1. We mentioned that last class period. What's the next perfect square? 4. Not 2. 4. The next one is 9 because 3 squared is 9. The next one is 16 because 4 squared is 16. Next one is 25 and so on. All right, so there are an infinite number of perfect squares. Okay, so in number 1, you want to factor these. Now, these are going to be the difference of two squares they're going to look at. And so number 1, you have x squared minus 9. Now, that's not a trinomial. So remember what we've been dealing with the last week and a half to 2 weeks have been factoring trinomials. This is a binomial. Why is this a binomial? It has 2 terms. Okay, now, same as before, you want to look for the GCF. What's the GCF? 1. GCF is 1. All right, so GCF is 1. If the GCF was something other than 1, as in the past, you would factor out the GCF. But the process is still the same. You want to factor this as a product of 2 binomials. Okay? You want to factor this as a product of 2 binomials. Well, you can kind of guess as to what this may be, just like before we did the FOIL method. When you looked at FOIL, what times what is x squared? X. What times what is 9? 3 and 3, 9 and 1. What do you want to try? 3 and 3, okay? Now, the last sign is negative. What does that imply by these signs in here? They're different. And you might say, but there's no middle term. Well, that's okay. There doesn't have to be a middle term. And so if I make this positive, this negative, and I FOIL it out and I check myself, what's x times x? X squared. What's the outer? Negative 3x. What's the inner? Positive 3x. Those add up to be 0, right? And then what's the last? Negative 9, which is what you wanted. All right, so this right here, though, is called the difference of 2 squares. This is the difference of 2 squares. And here's the idea about the difference of 2 squares. If you have the difference of 2 squares, you can always rewrite that binomial. Now, remember when we talked about the perfect squares last class period, remember how I wrote this as 1 squared, 2 squared, 3 squared, 4 squared, and so on? Remember all that? Okay? And that gave us these numbers up here. So whenever you have the difference of 2 squares, if this binomial does represent the difference of 2 squares, you can always rewrite each term as a factor squared. You can always rewrite this as something squared. All right, so whenever you factor in the difference of 2 squares, what if it is, what you're ending up with is that each term will be something squared. So I'm going to call this F for right now, and I'm going to call this L for right now. So F squared minus L squared. And so if you look at this right here, can I write these 2 terms as something squared minus something squared? Yes. And so it does help. Now this one's pretty easy not to do what I'm about to do, but many of them, for some of you, is a good idea to do this. So you want to rewrite this as something squared minus something squared. And if I can fill in those parentheses, then that's the difference of 2 squares, and then I can factor it very easily. What times itself is x squared?
X.
What times itself is 9? 3. So I filled in the parentheses, which means that this is the difference of 2 squares. Now notice what happens. You see how I have x plus 3 times x minus 3? The first terms are alike, the last terms are alike, except what's the difference? The signs. And so when I have the difference of 2 squares, I can factor the difference of 2 squares as f minus L times f plus L. F minus L times f plus L. That's what I have here. X plus 3 times what? X minus 3. Notice the f's are the same, the l's are the same. The only difference is the sign. All right. And so that means if I can fill in these parentheses, then this right here is my first, my f, and this is my last, my L. And so then I can factor this as two binomials, x minus 3 times x plus 3. All right, so the idea is to first of all see if it is the difference of two squares. For example, number 2. What if I had this? 4x squared minus 25, let's say. Is that the difference of two squares? You need to be able to see that it is or is not very quickly. Yeah, first of all, what's the GCF? 1. All right, so you said it's the difference of two squares. So if you're saying it's the difference of two squares, then I can write each term as a factor times itself. What times itself is 4x squared? 2x. So what goes inside the parentheses? 2x. What times itself is 25? 5. And so therefore, this right here is the difference of two squares, and I can factor it as two binomials. This is your f, the 2x, and the 5 is your L. So what's the answer? 2x. Plus or minus does not matter what you put first. Just tell me what to put. Minus 5 times what? 2x plus 5. So everything is identical except for the signs. And you can fill it out. You'll see that you get this binomial back. For example, if I check it, what's the first? 4x squared. What's the outer? 10x, right? What's the inner? Minus 10x, and those cancel, right? And then what's the last? Negative 25. So you get 4x squared minus 25, which is what you wanted. Okay? Now, I want to make a point that writing it like this, that's not the answer. You're just checking to see in your mind if this can be written as something times itself and then minus a factor times itself. Okay? All right, so that's answer number 3, this right here. Number 2, rather. All right, number 3. What if you had this? 4x squared minus 25y squared. First of all, look for GCF. What's the GCF? 1. How many terms do you see? 2. So far, all you know is that if you have 2 terms, the only thing we've been dealing with at this point was the difference of 2 squares, right? So is this the difference of 2 squares? Okay, so if it is, then that means I can rewrite the first term as something times itself minus, and then the last term as something times itself. What goes inside the parentheses?
2x.
Very good, because 2x times 2x is 4x squared. What goes inside the parentheses here? 5y, because 5y times 5y is 25y squared. So basically, I have the answer, or I know what the answer is. What are my two binomials? 2x plus 5y, 2x minus 5y, and that's it. That's your answer. Number 4, what if you had this? Number 4, all right, number 4, what if you had 2x squared minus 18y squared? All right, 2x squared minus 18y squared. All right, so first of all, remember, always look for what? GCF. And then even if you didn't factor out the GCF, you knew something was wrong, because what times itself is 2x squared? Yeah, 2 is not a perfect square, right? Remember, your perfect squares are 1, 4, 9, 16, so on. 18 is not a perfect square, so you know something's wrong. So you have to do what first? GCF. What's the GCF? 2. So this becomes 2 times x squared minus 9y squared, right? All right, now think about what we've been doing the last 2 weeks with factoring. Am I done? No. Because see that, remember, for the worksheet was due today, if you can factor out the GCF, you got to look and see if you can factor what's inside the parentheses still. So if I go and I rewrite x squared minus 9y squared, is this the difference of two squares? Yes. Because I can write this as the difference of something times itself minus something times itself. What goes inside this parentheses? X inside this one. What goes inside this one? 3y. So if I can fill in those parentheses, then that is the difference of two squares. What is it? X plus 3y, x minus 3y. And so therefore, what's the answer to the original problem? 2 times x plus 3y times x minus 3y. Okay? All right. Difference of two squares is a fairly easy idea for students. What if you had this? 3w squared minus 48. 3w squared minus 48. What do y'all think? What? So, I'm sorry, say it again? I can't hear you. Okay, the way it's written, it's not, I agree, 48 is not a perfect square, but you're forgetting something that's very important.
The GCF.
The GCF.
It's 3.
3. GCF is 3. So you got to say GCF is 3, so I'm going to factor out a 3. All right, first step. What do you get? 3 times w squared minus 16? Okay, so that's where I'm at. Am I done?
No.
No, because you need to check and see if you can factor w squared minus 16. Well, I have two terms. There's a minus sign between them. So let's check and see if this is the difference of two squares. Is it?
Yes.
Yeah, what goes inside the first parentheses? W. What goes inside the second? 4. So what do I get when I factor this binomial? W.
Wait, 3.
No, I'm just looking at this binomial right now first.
Sorry.
W. Minus 4. I'm sorry, yes. W
4.
plus 4. All right. Now, what's the answer? 3 times.
3 times w minus 4.
Very good. 3 times w minus 4 times w plus 4. All right. So that will be the answer for that one. Number 6. What if you had 5a to the 4th minus 45 a squared b squared?
Oh my gosh.
All right, so 5a to the 4th minus 45a squared b squared. What? Very good. The GCF is 5a squared. I agree with that. So I'm going to factor out a 5a squared, and when I factor out 5a squared, what binomial do I have here? A squared minus 9b squared. All right, because 5a squared times a squared is 5a to the 4th. All right. Now, you need to make sure that this binomial cannot be factored any further, or if it can be factored further. Is that the difference of two squares?
Yes.
Yes, because I can write a squared as what times itself? A. And I can write 9b squared as what times itself?
3B.
3b. So notice I wrote it as the difference of two what? Squares. I wrote this as the difference of two squares. That's what this is. Now that's not your answer for factoring, because you got to write it as two binomials, as a product of two binomials. So what do I write here?
5A squared.
No. Let's do this in first. A minus 3b, a plus 3b, and what's the answer there?
5A squared.
Okay? A minus 3b, a plus 3b?
Yes.
Okay? All right, so that's that. So that's that one. It's a very easy process. Number 7, what if you had 100 minus 9/4 n squared? Now don't let the fraction throw you off. All right. So how many terms do you see? 2. All right. There's a subtraction sign in the middle, right? So let's check and see if this is the difference of 2 squares. Difference of 2 squares. Now, notice 100 is a perfect square because what times itself is 100? 10. 9 is a perfect square. What times itself is 9? 4 is a perfect square. What times itself is 4? 2. So is this the difference of 2 squares? Yes. So if I look at it, what goes inside the parentheses here? 10. All right. Now, what goes inside the second parentheses? I have 9/4 in squared. 3 divided by 2 times what? N. Very good. So that's what goes there. Because 3 halves times 3 halves is what? 9/4. N times N is N squared. And so therefore your answer will be what? 10 minus halves N times 10 plus 3 halves N. Okay. And then number 8. Look at number 8. Number 8, we have r to the 4th minus 49. R to the 4th minus 49. Okay. Now, let's check in. Well, first of all, what's the GCF? 1. So let's check and see if this is a difference of 2 squares. So if it is, I can fill in these parentheses. The 49 is easy. What times itself is 49? 7. All right, now think about r squared. I'm sorry, r to the 4th. What times itself is r to the 4th? R squared. And so when I factor this then, so this is the difference of 2 squares, and when I factor it, what do I write? R squared minus 7 times r squared plus 7. Now I'm going to come back to, now this is the answer for right, this is the answer. I'm going to come back to this though in a little while because there's something else I want to talk about this. Yeah.
You said it doesn't matter which one you put first out of the word.
No, it doesn't, because remember multiplication is commutative. The order in which you multiply does not matter. So 3 times 5 is the same as 5 times 3. R squared minus 7 times r squared plus 7 is the same as r squared plus 7 times r squared minus 7. So it does not matter. But I need to come back and talk about this a little bit further in a little while. Okay? All right, now there's one, it's either in the worksheet or my math lab, it will ask you this. So I'm going to put this as number 9. What if I had this, negative 1 plus 36k squared? Negative 1 plus 36k squared. What do you think about that one? Huh? Well, okay, so you're saying it's a perfect square. So is negative 1 a perfect square? No number times itself is negative 1. In fact, a number times itself will either be 0 or positive. It's never negative. Tell me something else about number 9. Say it again. Okay, so you could factor out a negative 1, but that's not what I want you to do. But that's a good point. You can factor out a negative 1. Rewrite it. How? No. Put 36x squared. Put 36k squared first. Put 36k squared first. So that's 36k squared what? Minus 1. And now you'll notice that I can write this as the difference of 2 squares. What times itself is 36k squared? 6k. What times itself is 1? 1. So it's the answer. Minus 1.
6k plus 1.
6k plus 1. All right. So in number 9, it was a lot easier to rewrite it. Now, she mentioned factoring out a negative 1 because on one of the worksheets, didn't it say factor out negative 1 on a couple of the problems that was due today? All right, let's do that. So you may say, well, I'm going to factor out a negative 1 instead. Well, that's fine. Let's see what we get. So that's going to be negative 1 times what, though? 1. What else? Minus 36k squared. Because a negative 1 times 1 is a negative 1. A negative 1 times a negative 36k squared is a positive 36k. Now look at that 1 minus 36k squared, though. Is that the difference of two squares? Yeah. What times itself is 1? 1. What times itself is 36k squared? 6k. So how do you factor this, though? 1 minus 6k times 1 plus 6k. And so then your answer then would be what, though? Negative 1 times these two things. All right, and so you may say, but those look different. Well, yeah, it does, because here you factor out a negative 1. Here you rewrote it where you didn't have to factor out a negative 1. But they are the same, they just look different. Because watch. You see this one right here? 1 plus 6k? Is that the same thing as this one? Yes. 1 plus 6k is the same as what? 6k plus 1. All right. Now you see this 6k minus 1? Well, that's this right here. Because if I distribute the negative 1, what's negative 1 times 1? And you see that negative 1 right here? What's negative 1 times a negative 6k? Positive 6k, and that's what this is. All right. So they are the same thing. They just look different.
So which one do you prefer?
Does not matter. I would have done it this way. Because some students, when they factor out the negative 1, they tend to mess up with one of the signs. So it doesn't matter, but I would have just done it that way. Does not matter. Okay? All right. Okay, so that was the difference of two squares. It's a fairly easy thing. Now, I want to ask you this, though. All right, so we know this. That x squared minus 9 I can factor as how?
X plus 3.
X plus 3,
X minus 3.
x minus 3. Because this is the difference of two squares, isn't it?
Mhm.
But what about this? X squared plus 9. How would you factor that one? So we know that x squared minus 9 I can factor as x plus 3 times x minus 3. What about that one? What do y'all think?
Wouldn't they just both be plus?
I'm sorry, say it again?
Wouldn't they both be plus? Like
When they both be plus? Okay, let's try that. So you're saying you think that it's going to be x plus 3 times x plus 3, right?
Mhm.
Okay, let's check it. What's the outer? I mean, what's the first? X squared. What's the outer? 3x. What's the inner? 3x. So you saw it's not true, right? And what's the last? 9. So when you combine like terms, you get x squared plus 6x plus 9, but that's not what you started out with. So no, it cannot be that one then. You want to try something else?
Mm.
What do you mean the reciprocal? I'm just wondering what you mean by that, the reciprocal.
Turn it into fractions so you can switch the sign. Like 9 is known as 9 over 1, but if you switch it, you can switch the sign.
Okay, so 9 is 9 over 1, but if you switch, what do you mean by switch? You got to be a little bit more detailed.
It's just a guess.
Well,
I don't know.
no, I mean, you're just not telling me enough to where I can understand what you're saying.
So, last semester I thought that if you do the reciprocal, you can switch a sign. So if you have
The
x
reciprocal
squared,
of 9 is 1/9. Why would you want to change 9 to 1/9?
so that you can change it to a negative.
That no, you don't. So you're saying you're saying that this right here is the same thing as saying r squared minus 1/9? That's not true. Those are two different things. That's not true. So I'm not sure what. Yeah. So that's a misunderstanding from last semester. Okay. All right. So what else were you gonna say? What do y'all think? prime. Cannot be factored. This is prime. Now here's the thing. Do y'all remember a while ago we called this the difference of two squares? And we call this difference of two squares because I can write this as the difference of two squares. What goes inside the first parentheses? X. What about here? 3. So that was the difference of two squares. This, if I look at x squared plus 9, that is the sum of two squares. That's the sum. See sum plus symbol? This is what symbol? Subtraction, difference. This is sum. This is the sum of two squares. What goes inside the parentheses? X and what? 3. Well, remember now that the sum of two squares cannot be factored. Sum of two squares can't be factored. Okay? Sum of two squares cannot be factored. So, if I wanted to factor this, let's say you want to factor 9x squared plus 49. 9x squared plus 49. Right away, you need to ask yourself, what's the GCF? 1. How many terms do you see? 2. The only thing we know about two terms is this so far. Is it the difference of two squares or is it the sum of two squares? That's all we know. Is this the difference of two squares? You better say no right away because you don't see a what here? Subtraction. So it cannot be the difference of two squares. There's no subtraction symbol. So then that only leaves you at this point, well, is it the sum of two squares?
Yeah.
It is. It's the sum of two squares. But what do you notice about the sum of two squares? Can be factored. So you just say prime. This is prime because that's the sum of two squares.
So every time it's a plus sign, does that mean it's prime?
No. So so her question's this. So every time you see a plus symbol, does that mean it's prime? No. I mean, if it's a sum of two squares, then yes, it will be prime. Okay, so what if I had this? What if I had 6x squared plus 12? I see a plus symbol. Am I going to say prime?
GCF is 6.
No, because there's a GCF. What's the GCF?
3.
No,
What? 6.
6. GCF is 6. So I get 6 times x squared plus 2. Okay? So that's your answer. You don't say prime because I can factor. Remember, one thing of factoring is to use a GCF. Now, what if I had this? 6x squared minus 12. What would that be? Okay, GCF is 6. You got to do that first. Times what? X squared minus 2. Now, look at what you have here. Is this the difference of two squares? No, because 2 is not a perfect square, so there's your answer. You're done. What if you had this? 6x squared minus 24. 6x squared minus 24. What can I do first? GCF. What's the GCF? 6. Times what? Minus 4. Am I done? No, because this is now the difference of two squares, because 4 is a perfect square. See, this, you were done here because 2 is not a perfect square. Here 4 is. So how can you factor this? What would be the answer for this one? X, not minus 4, minus 2 times what? X plus 2. That will be your answer. So knows the differences between these two. This you are done because that's not the difference of two squares. 2 is not a perfect square. Here, 4 is a perfect square, so you can go further. Okay? All right, so at this point, you've learned about the difference of two squares and the sum of two squares. And the sum of two squares cannot be factored. All right, so if you had this, let's say you had this, 6x squared plus 24. Is this prime? No. Why not? GCF. So I can factor this as 6 times what? X squared plus 4. Can I factor x squared plus 4? Yes. How? She says yes. Do y'all agree with her? No. Because x squared plus 4 is the sum of two squares. The sum of two squares cannot be factored. So you're done with this one. So these are all little things you got to remember. Difference of two squares, sum of two squares, and so forth. Okay? All right. Now, let's look at this one now. All right. So that's pretty much the difference of two squares and the sum of two squares. You just got to know that if you have the sum of two squares, can you factor? No. So you may say this. Well, why didn't you said that this is the sum of two squares, so why didn't you say prime? Why not? Why didn't I say prime for this? Because I can take out the GCF. GCF was 6, so this is not prime. It turns out that one of my factors is prime, but that's still my answer. 6 times x squared plus 4. Don't confuse that with this. This was, the GCF was 1. So what I have left is the sum of two squares, and that is prime. Okay? All right, now, let's look at this.